Hello students. As we know, we are all in the quarantine period and we cannot meet each other. So therefore, I would like to give you all my best wishes, and all of you take very good care for yourself. And right now we are here to discuss spectroscopy. So, in organic chemistry, spectroscopy progresses. Is the most important part, so that a person can progress in organic chemistry. Once a person has learned how to illustrate, how to evaluate the spectra, different spectra, he can definitely very well progress in organic chemistry. So, what is spectroscopy? So, spectroscopy is actually whenever there is an interaction between electromagnetic waves and electromagnetic radiations and matter, we get a kind of structural information about the particular molecule of that matter, and that is what is actually analyzing our spectra is what you call as a spectroscopy, where we have got the spectra by the interaction of matter and electromagnetic radiations. So let us now move to the next part. What is done in the spectroscopic method? In this method, whatever is the molecule, whether it is inorganic or organic molecule, it is put in a path of monochromatic light, and by in that process the molecule either absorbs or emits certain radiations. Now, based on the magnitude of those absorbed or emitted radiation, one can actually get a scope of studying the property of that molecule. Now, how it is measured? It is measured by using certain instruments like spectrophotometer, spectrofluorometer, fluorometer, atomic absorption spectrophotometer, flame photometer, etc. Now, what is the relation between the molecule and the light? We study the relation by an equation like absorbance. What is the absorbance of the radiation and the concentration of the solution? Like here, if you see the equation, A is equal to ABC. Now, what is A? A is the absorbance. And B, what is B? I mean, capital A is the absorbance. What is small a? Small a is the absorbivity constant, and B is the path length, and C is the concentration of the molecular solution. Now here you can see the diagram. Here, if you see, this is the monochromator, means the light which from the source is giving light radiation, and this radiation is converted into a single wavelength that we call is a monochromatic wavelength. And once the wavelength is a particular wavelength passes through the sample will be absorbing certain amount of radiation and then emitting out the rest of it. Okay, so when it is emitted out, the detector will detect it, and the converter will convert it from the analog to digital. And now after the conversion, you can see it in the computer software, and that will give you the spectra. So here what the spectra will tell us, what amount of radiation has been absorbed by the sample. Okay, so based on that amount of radiation absorbed, you can actually characterize the molecule. Now, what is electromagnetic radiation? Electromagnetic radiation is a form of energy, and basically in spectroscopy we would require the particle nature of the radiation. You know, electromagnetic radiation has both the natures, means wave nature as well as particle nature. Now when we will be studying absorption or emission of light, we will definitely concentrate on the particle nature of the light. Okay, in case of particle nature of light, you know what are the terminologies. You have photons, that is a packet of energy. We will consider every light wave and light particle having a particular packet of energy. Okay. And the properties which we have to know is regarding the electromagnetic radiation is frequency, velocity, wavelength, wave number. Now, what is the relation between frequency and wavelength? It is frequency mu is equal to c by lambda. What is c? C is the velocity of light. What is the energy of the photon? Energy of the photon is equal to E is equal to h nu. What is h? H is the Planck's constant, and its value is 6.626 into 10 to the power minus 34 joules per second. Joule second. Now here you can see the total electromagnetic spectrum. So we have started with increasing frequency, means this is the highest frequency, and this is the least frequency, that is gamma rays having the highest frequency and the long radio waves having the least frequency. So here in the other side we have wavelength, and as the frequency is maximum in case of gamma waves, the wavelength is minimum in case of gamma waves, whereas it is maximum in case of long radio waves. Okay. Now, what are the role of these radiations in case of spectroscopy? The radiation which is under the category of ultraviolet, you can see it has a role in electronic excitation, and visible also has the same role, electronic excitation. Infrared has the role of vibrating the molecule, and accordingly a microwave can rotate the molecules. Okay. So that's the difference. So in case of UV visible, what you are studying is UV visible spectroscopy. What you are studying is the electronic excitation. In case of IR spectroscopy, you will be studying the vibrations of the molecules. In case of microwave spectroscopy or rotational spectroscopy, you will be studying the rotation of different molecules, which we will discuss very elaborately in the coming chapters. Now see, here we have already discussed this, you know it very well. Any electromagnetic radiation has the electrical and as well as the magnetic component. Both are perpendicular to each other. Here in this diagram you can see E, that is blue wave, is the electrical waves, and B, that is the red waves, are the magnetic field. Okay, and both this electric field and magnetic field are perpendicular to each other. What about the wave finally? The wave finally is taking a direction just in between the electric and magnetic wave. Here what you see is the the blue colored wave is the wave of the light, and red is the electrical component and green is the magnetic component. Now what is amplitude? Amplitude is the height of the wave. Okay, maximum height of the wave. And what is wavelength? Wavelength is the distance between any two peaks of the wave. Okay, and you have high frequency means short wavelength, low frequency means long wavelength. That we know very well. Now, spectroscopy can be classified into two types: absorption and emission. What is absorption? In case of absorption spectroscopy, the magnitude of the absorbed radiation is measured by an instrument and is related to the concentration of the analyte, that is this molecule, and we have already discussed about it. Now, absorption spectroscopy can be of two types: molecular absorption spectroscopy and atomic absorption spectroscopy. In molecular absorption spectroscopy, the molecule is irradiated by radiations, whereas in atomic absorption spectroscopy, the atom is radiated by the electromagnetic radiation. Now, molecular absorption spectroscopy can be of different types. UV visible is absorption, IR is absorption spectroscopy, NMR is absorption spectroscopy. Now you can see this one. So all these molecules will be absorbing the radiation, and we will be coming out. The molecule will be coming out with the lesser amount of radiation. In case of emissions spectroscopy, we again have molecular emission spectroscopy and atomic absorption spectroscopy. What we see here is the magnitude of the emitted radiation intensity is measured by an instrument and related to the concentration. That is, here in case of emission spectroscopy, the intensity of light is measured, whereas in case of absorption spectroscopy, absorbance of the emitted light is measured. Okay, so here what we have a change is in case of emission, it is